Welcome to my video on 13-4, the sine function. So today we're going to be looking at sine of x now as a function that can be graphed on a coordinate plane. Okay, so the aim of today is going to be to graph these sine curves and identify specific properties. So we're going to have a big vocabulary day today. So for the do now, I have the unit circle, right? We talked about the unit circle a little bit before break. Now we're going to take a little bit deeper look at it. And just as a reminder, I want you to answer the following question. Which value of the coordinate on the unit circle represents the sine value of a particular value? So, what am I asking? Well, when we look at our unit circle, will it be my x value or my y value that is my sine? And we hopefully remember that sine on the unit circle of our angle is going to be equal to my y value, okay? So of the unit circle, the values we're going to be paying attention pretty much for today are these. 0, 1/2, radical 2 over 2, radical 3 over 2, all of these, and those, okay? Now, we should notice that on the unit circle, there's kind of like a pattern, right? We have the same values of 1, 0, 1/2, radical 3 over 2, and radical 2 over 2, and they're opposites, meaning they're negative values. But those are the only numbers that we're really paying attention to on our unit circle, okay? So we're going to see how that kind of plays out when we go to plot this on a coordinate plane. But I don't know about you. I am not comfortable with the number radical 3 over 2. I don't know what that looks like in terms of plotting it on a coordinate plane. So let's talk about the decimal equivalents of these values. Now we should know 1/2 is equal to 0.5. And we should be able to plot that on a coordinate plane, right? It would be somewhere in between 0 and 1. But what about radical 3 over 2? Well, when you plug in radical 3 over 2 in your calculator, it's going to be 0.866. And radical 2 over 2 is going to be 0.707. Now, when you go to do trig functions on your calculator, those should be ones that are standing out to you. 0.5, 0.866, 0.707, because those are going to imply to us that we have our special angles. These are the angles that can be found on our unit circle. These are the angles we can find exact value for. So those are numbers that really should be popping out at you when you look at your calculator. So now we're going to take this idea and we're going to create a table, right? Every graph has a table of x and y values. So using the values on the unit circle, we're not going to worry about anything in between. I'd like for us to complete the following table. Now I attached the notes for you guys to fill in so that you can follow along with the table. So here I have the radians picked out for us that we're going to be looking at on the graph. All right, so if we have 0 radians, remember, if we're looking for the sine and we're going to use our unit circle for this, we are going to look at the y value where we have 0 degrees. Well, I should say 0 degrees radians, right? So we should be aware that the sine of 0 radians is 0. Okay. What about the sine of pi over 4? Now, I know we're not super comfortable with radians, okay? But for the most part, when you see graphs, trig graphs like these, they are going to be in radians. But just know that everything we do with the radians here, we can do with our degrees. So this pi over 4, which we hopefully know is 45 degrees, is going to be the same value as sine of pi over 4. Okay, and again, we could go to our unit circle and we see that that is radical 2 over 2. Now, we just talked about how to plot this. This is going to be approximately the decimal 0.707. Okay, so we're going to stick with the decimal equivalents for the rest of the table. So pi over 2, which we hopefully know is 90 degrees, gives us 1, right? Because we look at the y value. 3 pi over 4, you may not know off the top of your head, but I do, is about 135 degrees. That's this guy right here. And my y value there is radical 2 over 2, which we know is approximately 0.707. Now we get to pi. Pi we know is 180. My y value at 180 is 0. Pi over 4, which is 225, as you can see on your unit circle. That's going to be a negative 0.707. Okay, and 3 pi over 2, which is 270. We know the y value is equal to a negative 1. Negative 7 pi over 4, as you can see on the unit circle, is 315. That's going to be a negative, radical 2 over 2, which is negative 707. And 2 pi, which we know is equivalent to 0, right? We're back at 2 pi when we start, has the y value of 0. So now if we take a look at this table, right, we should hopefully notice a pattern, right? We start at 0. We kind of creep our way up till we get to 1, and then we slowly move our way back down to 0. Then we start in our negative numbers. We continue going down to the negatives. We stop at negative 1, and we make our way slowly back up to 0. So now we're going to look at how this looks on a coordinate plane. But before we do that, I want to continue this table, because if this kind of pattern follows from 0 to 2 pi, what's going to happen as we proceed forward? So let's take a look. So 2 pi we know starts at 0. Okay, now the unit circle doesn't have any of these angle measurements. These are the angle measurements that are going to be greater than 360 degrees. Okay, if I will put the equivalent degrees just so you can get an idea of where we are. But we're going to be working with our graphs with our radian values. Okay, so now you can use your calculator for this. The one thing you want to make sure that you do is make sure your calculator is in radian mode. Now your calculator should automatically be in radian mode if you have not changed it. But remember, you can press the mode key. Just make sure the little black box is around radians. You will not get the correct values if it is in degree mode. Okay, so in your calculator, you can just type in sine of 9 pi over 4, and it should give you the value 0.707. Now, although we know this is not the equivalent because it's a decimal approximation, that 0.707 should be ringing a bell in our head as the radical 2 over 2 that we saw in our unit circle. Okay, and that's because this is 405 degrees, which ends up having a reference angle of 45 degrees. All right, so let's continue. You type in sine of 5 pi over 2. That's equal to 1. Now, this is actually equal to the angle measurement of 405, which has a reference angle of 90. So we continue. 11 pi over 4 gives me 0.707. That's the 495. 3 pi gives me 0. That's equal to 540. 13 pi over 4, you type it in. You get this value, which is 585 degrees. 7 pi over 2 is negative 1. 630 degrees. 15 pi over 2 is negative 0.707. 675. And 4 pi is 720. Okay, so what you should notice is that this table, if I kind of squeeze out there for a second, is exactly the same as the table we just looked at, right? We start at 0, we make our way up to 1 and then back down to 0. Then we go down to the negative 1 and come back up to 0. It's the same pattern, even though the degrees are getting continuously bigger and bigger by 45 degrees or by pi over 4 radians. Okay, so what we see here is a repeating pattern. So let's see how that looks on my graph. Okay, so this graph is also in your notes. Now we will talk about how to set up these axes, how to pick the values to label it with. But for now, I have it set up for you. And you'll notice I have it set up so that each line is worth pi over 4. Okay, so the table that we have, we can just plot directly on here. Now you'll notice my maximum value on this graph is 1 and negative 1 because I didn't see any values bigger than that. Okay, so let's start plotting. We start with the first table. At radian measure 0, we had 0. At pi over 4, we had 707, which, if these are each worth 0.25, is going to be somewhere over there. Pi over 2 should be 1. 3 pi over 4 comes to 0.707, and we get 0 at pi. We continue. Now we're in our negative values, and you will notice that you will get this shape for the first table. Okay, now because the second table is exactly the same, we should see this shape repeat itself. Okay, so let's keep plotting. We started 2 pi is 0, 9 pi over 4 is 0.707. We get a 1, and we continue. Okay, and if you follow those values, you do get the exact same shape. So what are some things we should notice about this graph? Well, it looks like it repeats itself, even though the numbers keep getting bigger. And now, how often does it repeat itself? Well, it looks like it repeated itself again after 2 pi, and then made itself back to 4 pi. What should we expect when we get to 6 pi? Another one of these shapes. Now, these shapes are called a cycle. I will give you the formal vocabulary for that later on, but a cycle is basically one complete pattern shape on your graph. Okay? What else should we notice? Well, we see that there is a maximum and a minimum value. In this case, we have a maximum of 1 and a minimum of -1. Now, those values are going to change when we start adding things to this sine of theta, but that means every sine graph is going to have a maximum and a minimum value. Okay, so that's what this slide is asking. What's the maximum and minimum value? My maximum is 1. My minimum value is -1. And the graph of sine of theta repeats itself every 2 pi radians. Now, in degrees, you should be aware that 2 pi is equal to 360. So the same patterns that happen for every 2 pi will also happen for 360 degrees. So again, most of the questions you'll see will be in radians, but if they do happen to use degrees, the same patterns will follow for 360 degrees. Okay, so that brings us to our vocabulary for the day. Well, the first set. So a sine function we see has a special pattern, right? It kind of goes up and it goes back down, and it starts and ends at 0. This is called a periodic function, and the reason it's called a periodic function is because of that repeating pattern. All right, there are lots of different periodic functions out there, but we're going to focus on the fact that sine is a repeating function. Okay, this pattern continues indefinitely forever. We talked about a cycle. The cycle is the shortest repeating portion. So for my sine graphs, it will be this shape, starting down here, going up, down, and back to start. Okay, that is a cycle. And that cycle repeats itself because it is periodic. Now, that 2 pi that we talked about, right, how long it took for the graph to repeat itself is what we call our period. Okay, it is the horizontal length of each cycle. It's the x values or the theta values for which we have one cycle. So in this graph that we have here, 0 to 360 is our period. So our period is 360. If those were in radians, our period would be 2 pi.